velocity is constant, uniform velocity motion. So already let's go back to the definition of instantaneous speed, V instantaneous. Now, what is the method? Slope of tangent drawn in ST graph will give instantaneous velocity. And look at the slope for this curve for 0 to 4 seconds. What is the slope? 10 by 4. So therefore, what is there for T? For T between 0 to 4 seconds, the instantaneous speed is given by, I'll just write V in, or okay, we'll use same symbol, no problem. How much it will be? 10 minus 0, 4 minus 0. This will be 5 by 2 or 2.5 meter per second. Now, what is the slope of the curve for T less than is 0? What do you mean by that? What is the slope? Slope will be 0, no? If a line is horizontal, if it is a parallel to x-axis, the slope must be 0. I think you know very well the same thing. The slope of the curve in the interval of time 4 to 7 seconds will be 0. Okay, let's come for this one. For the interval of time. What is the slope? Slope will be negative. It will be 5 minus 10, 9 minus 7. So minus 5 by 2. So 2.5 meter per second. What do you mean by negative? The velocity negative means, what does it mean? It is changing its direction of motion. So how that motion occurs practically? Okay, the E is what very important. So let's start like this. First, it will cover a distance of 10 meters. Then afterwards, it will start moving in the reverse path. Let me indicate two curves. So there's a first, it will move along positive x-axis. Next, it will start moving along the negative x-axis. So here it will move with a speed how much? 2.5 meter per second. Here it will move with a speed 2.5 meter per second. The total distance, how much it will cover? 10 meters. Next, it will move 5 meters. So how that motion actually occurs? For first 4 seconds, t equal to 0, it will be here. Until 4 seconds, the body will cover a distance of 10 meter with a speed 2.5 meter per second. It will come here. Then next for another 3 seconds, it will not move. It will be at rest. So even t equal to at 7 seconds also, the body will be there only. Then it will start moving towards left. I think it's very simple. No, you just walk for 4 seconds. Then for another 3 seconds, you don't walk, you be there only. Then another 2 seconds, you reverse, come back, and like a return journey, you make it 5 meter, you walk in the return path. Then you are going to finally stop here. So like we have just made it here, that one. It's not like I didn't make any horizontal line, just here. Till here, what we have to discuss the motion. So next again, finally, you are here at 9 seconds. So how the motion occurs? First, you are going to walk for 4 seconds. Then another 3 seconds, you don't walk. Then another 2 seconds, you are going to take the return path. So what is the total distance moved by the vehicle? 10 meter plus 5. So the total distance moved will be distance covered will be 10 plus 5, 15 meter. Then average speed is asking. How you define average speed? Distance covered by time taken. 15 total time of journey, 9. This will be the average speed. What about average velocity? Displacement by total time. What is the net displacement? This is the initial. This is the final. What is the net displacement? 5 meter, no? Final portion minus initial portion. So this will be 5/9. Average velocity it is. This is average speed. So from position versus time graph, can you calculate the instantaneous velocity S? That's what I'm showing. So what is the speed of particle at 2 seconds? 2.5. What is the speed of particle at 5 seconds? 0. What is the speed of particle at 8 seconds? Somewhere here. Minus 2.5. So can we predict in what direction it is moving from position versus time graph? S, the slope. The object is moving towards left, you see, after 7 seconds. If the slope is positive, the object is moving along positive x-axis. Slope negative, the object is moving along negative x-axis. So from ST graph, we can predict the direction of motion. I think I'll write all the conclusions here from ST graph. ST means position versus time graph. What all you can calculate? Instantaneous speed. We can find or determine, we can find instantaneous speed. This is the one thing. Next, direction of motion. Third, distance covered. Fourth, displacement. Fifth, average speed. Average velocity. All these quantities you can determine. By slope, what happened? We can find out instantaneous speed. This is very important. The slope in FT graph will give the instantaneous speed. So, and the speed is constant. You see, everywhere for 0 to 4 seconds, the slope is constant, speed is constant. So, uniform velocity motion. For 0 to 4 seconds, what is the type of motion? Uniform velocity. Then, for 4 to 7 seconds, body will be at rest. I'll write all these things. What is the difference? For 0 to 4 seconds, body will move with this much of speed. 4 to 7 seconds, body at rest or vehicle at rest. Now, vehicle moves along positive x-axis. What about here? Negative sign. Vehicle moves along negative x-axis. It will change direction of motion. So all this information is readily available in this FT graph. It's very, very good. Lot of information. Just the mere graph, no, you can see that so much of things we are exploring. Able to analyze? Let me save it. Okay, let me take the next problem. So I think the ST graph, position of time graph, is really very, very important. Almost the total motion we are able to describe. So therefore, in the books, no, rather than expressing something instead of say like a instead of describing so much, no, I'll just put graph. The graph will speak so much of things. That's why you have so many numericals based on the graphs. This much of information is hidden in the graph. This is the idea. This total, what all I scribbled, everything is there in the graph. Getting the method. So definitely what happened? The interpretation of graph in kinematics becomes very important. What you have to interpret? Slope in a given graph, the slope at a point, what quantity it will reflect. Then area under the curve, what it will reflect. positive or negative, if the value is positive, negative. So what do it indicate? I think these are the three things. If you can notice, they'll be sufficient. I think everyone knows now slope in mathematical tools. You have learned the